Good afternoon, physicists! Today, on our latest edition of Physics, the rules for multiplying and dividing with significant figures. You already have mastered the art of doing addition and subtraction with significant figures, but that is but only a piece of the puzzle. Now we shall encounter multiplication and division. Thankfully, I think you will find that this round of handling sig figs will be much simpler than addition and subtraction. So strap in, get ready, and let's begin. In similar fashion to when we were doing addition and subtraction, we are going to actually be minimizing the number of significant figures in our answer. In other words, as we do a calculation with two or more numbers, whichever number has the smallest amount of significant digits will determine the amount of significant digits in our final answer. So similar to past rules, let's actually see some examples. Here we go, round one. We're taking 436.43 and multiplying it by 25.29. Step one, I must determine how many significant figures are in my two contributing numbers here. So the first number has a total of 5 significant figures, and the second number in my multiplication has 4 significant figures. Next, I'm going to actually do the multiplication and see what is my raw answer, or what do I just get as a number without any rounding involved. In this case, it comes out to be 11,720.1447. Holy number, Batman. This is clearly going to be rounded. And how many significant figures I round to is determined by which of these numbers at the top that I looked at in step one has the smallest number of sig figs. Well, in that case, it would be the 25.29. There are only 4 sig figs here. So that means my answer will be rounded to 4 sig figs as well, which means I'll have 1, 1, 7, 2. Okay, there it is. There are my 4 significant figures. And then I'll put a 0 in afterwards, but keep in mind that this is a placeholding 0. It is not significant to my answer at all. Going fast and furious. Here is another example with multiplication. Like the prior example, I'm going to start by looking at what are my significant figures in each of my individual numbers. Well, 117.5 has 1, 2, 3, looks like 4 sig figs there. And then 20 has a single sig fig. It is that 2 at the front. So that means that my rounded answer ultimately will have to have 1 significant figure only. So for my rounded answer, before we do that, I need to get my raw answer, which comes out to be 2,350. Now I need to round that to a single sig fig, which will be the first 2, because the 3 next to it tells me I'll round down to 2. And then after that, I will just have 3 zeros as my placeholders. So in this particular case, my answer is 2,000. Here comes another one. So before I get into explaining this, you are actually going to do the first step here. We have 25 times 146.53. Take a moment, hit pause, identify how many sig figs are in 25, how many sig figs are in 146.53, and then therefore how many sig figs will our final answer have when rounded. Let's see how you did. So for 25, we have a grand total of 2 sig figs from the 2 and from the 5. And then on the other hand, with the 146.53, you have a total of 5 sig figs. So if you said that our final rounded answer will only have 2 significant figures in it, then you are correct, and I give you an internet pat on the back. Good job, physicists. So let's figure out, okay, what is 25 times 146.53 before rounding? This is what I got. 3,663.25. Clearly more than 2 sig figs here. So I'm going to pause again. Think about it. Remember, we're rounding our answer to 2 sig figs. What will our final answer be? All right, if you said that our final answer would be 3,700, then you get the smiley face. Good job. Here's how we get 3,700. We know we're rounding to 2 sig figs. So I have to look at my raw answer and look at the next digit out. Remember, that dictates how I'm going to round. In this case, it's a 6, which means I am going to round up, which means the 6 next to it becomes a 7, and that's how we get 3,700. Remember, the zeros afterwards, they're not significant, they're just placeholders. Physicists, this one is all you. I am going to let you try to figure this one out, and then I am going to give you the answer. But if you get it wrong, it's okay. You still have the answer. See if with that answer you can then go back and figure out how I got my final rounded answer. If you're still confused even after having the answer and trying to work backwards, hang on to that question, save it for tomorrow, and we can go over it in class. That's fine. The final answer for this example should be 4,790. And if you got that correct, I'm giving you 2 thumbs up through the screen. If you got it incorrect, that's fine. See if you can figure out where you made a mistake. And if you're still stumped after a few minutes of thinking about it, looking it over, bring it in for tomorrow. We can go over it together. Guess what, physicists? When it comes to division, it's going to be the exact same process as with multiplication. It's just we're doing the opposite operator now. So if we take 751.1 and divide it by 50, let's count up our sig figs for 751.1. I count uno, I count dos, I count tres, I count cuatro. I see 4 total significant figures in 751.1. And then I will do the same for 50. I see a grand total of 1 significant figure in 50. That means our rounded answer will have 1 sig fig in it. So, doing this actual division, what is our raw answer? First off, looks like about 15.022, which most certainly does not have 1 significant figure in it. So let us round. And I'm looking at first the 5 here. That's going to determine how we round it. Now remember, when we're rounding with a 5, it's not always going to be up necessarily. We're going to round it so that the digit in front becomes an even number. In this case, we could either round it down to 10, but that 1 will still be odd in that case. So we will actually round up to 20. So that first digit in our only sig fig becomes a 2. And therefore, our final answer here will actually be 20. There you have it. In similar fashion to our last multiplication example, I'm only going to give you the answer here. I want you to see if you can figure it out for yourself first. Compare it to my answer, and then if you get it wrong, try to work backwards. If you're still not getting it, keep it for tomorrow. We'll go over it together. And for this particular example, your final answer should come out to 267. And if you got that correct, you get the big smiley face. Good job. And if you had some trouble with it, think about that final answer and how did I get that? Remember your rules for sig figs. That's all I have for you today, physicists. Till next time.